We're ready for the next session. In this next session, I'm happy to introduce Dipti Borkar, who's our Director of Product Management, and J. Chris, as he's called, right? And he's our mobile architect, and they're going to talk about Couchbase for mobile. Take it away.
Great. Thanks, Yassine. So you will be mobiled out today, right? Through all these mobile sessions, we want to make sure that you understand the technology, understand what Couchbase Lite, Couchbase Sync Gateway, and Server can do for you as a part of building your next generation applications. So today we introduced Couchbase Lite. Couchbase Lite is the only NoSQL database for mobile, and this completes the solution for us. So let's actually take a look at what that solution is. We started off with Couchbase Server. Couchbase Server is the clustered NoSQL database. It could either run on-premise or in the cloud. We added Couchbase Lite, which is your native database for on-device, iOS and Android. And then to this, we added Sync Gateway, which completes the picture, completes the Couchbase solution for you to build a mobile data management stack to build your applications. Your applications run on the device. Thank you. Your applications run on your device natively, locally, and easily sync back with the cloud in one page of code. And so later this session, Chris will actually talk about and show you how it's done, what the sync code looks like, how easy it is to get set up and get started. So as we look today in the morning session, the strategy is JSON anywhere. And this really comes from the flexibility and the power of JSON, where it's easy to use. You have schema flexibility. You can represent all kinds of data, all sizes, all shapes of data. And now you have JSON on your device with Couchbase Lite. You have JSON on the wire. And you have JSON on the cloud in Sync Gateway, as well as Couchbase Server. So let's take a look at the architecture of what it actually looks like. Couchbase Server gives you the cluster database in the cloud. And currently, customers either deploy it on-premise, so they'll have their own install of Enterprise Edition in their data center. You might have a managed hosting that deploys it as well. Or you might just run it on Amazon. You could bring up a couple of AMIs, or Couchbase instances, which includes Sync Gateway now. So you have the ability to click a button on Amazon and bring up a Sync Gateway and a database at the back and get started. Or you could use Couchbase Cloud, which is our sandbox that was available as of today as well. So you can create your backend in the click of a button. Next, you have Sync Gateways. Sync Gateways are a component that's easily scalable. So they're stateless in that you can add as many Sync Gateways as you want, as you go, as your application grows. And you can have clients that connect to a specific Sync Gateway. You can have maybe 1,000 or 10,000 clients on a Sync Gateway. If you need more, bring up another Sync Gateway, one or two, and keep going. So as your application grows, as the number of clients and the devices connected to your backend grow, you can scale this out. You can scale this out by adding Sync Gateways. Of course, you can scale the backend cluster by adding nodes to the cluster. And then finally, Couchbase Lite, which is on the device. We have native iOS, which is written in Objective-C, and native Java for Android. So let's actually take a look at some of the features. What does Couchbase Lite include? What are the key features, and why does it matter? First, it's ultra lightweight, so very small footprint. It's secure JSON, so iOS, for example, is built within the iOS, the container of the operating system. Native support for iOS, Android, and we also have a PhoneGap plugin that I think Chris will be actually using today. And then finally, full document support, so reading and writing documents, indexing documents on the device itself, attachments, which is extremely powerful for pictures, images, files, whatever you can think of. And then finally, powerful conflict resolution. Without conflict resolution, it becomes really hard to build collaborative applications because you want a system where anyone at any point can update, read, write data. And with this, you get powerful conflict resolution that's based on revision IDs. We track these revision IDs, and we resolve conflicts at various points. So what do you get? What you get is the ability to build a brand new class of applications. As Yassine said this morning, we give you the data management tier. We give you the platform. We give you the ability. What you do with it is really what we're interested in. Pick this up and build that next application. We have democratic checkers. Maybe you want to build democratic monopoly. It's taking that to the next level to build productivity applications, perhaps, where you can be on the plane, you can be on a cruise, still able to make changes and use the application. Once you're back online, you can connect back and get synced with everything that you don't have updates for. Rapid development, of course, using JSON, and a highly responsive application. There's times when I use my Flipboard application or even Facebook, for example, and it takes a while to load all my feeds. If only it knew what I wanted as a channel that I'm subscribed to, and if only when I was sleeping, it populated all that information so that when I'm up in the morning, the first thing I do is obviously not look at Facebook. But if I did, I can look at all what my friends have been up to, what's going on in Asia, for example, and so on. And then always available wherever you are. And I think this is the beauty of occasionally connected devices, occasionally connected applications. You can be anywhere at any point and have access to that application without it being just a cache, without it being just old data. It's actually current data, which will then get synced once you connect. So JSON Everywhere gives you that flexibility, and Easy Sync gives you the ability to sync locally. But let's take a look at the sync part. We've talked a lot about JSON, but how does it actually work? How does the sync work using Sync Gateway? So with Sync Gateway, you get the ability to dynamically sync back via sync functions. And we'll actually take a look at how simple a sync function can be, how easy it is to write and connect. The basic concept is we have the notion of channels, and I'll talk a little bit about channels in just a bit. But a channel allows you to allocate a specific document logically to a group, which is a channel, and different users, different clients can subscribe to a channel. And it's a pretty powerful concept because just using this channel, a single channel, you can build one-to-one applications where I just want my data synced back with the cloud, one-to-many applications where I have my data synced to all my devices, my iPad, my phone, my laptop, or to my other friends collaboratively, or many-to-many, which is checkers, where you have many people updating your data at the same time, and also being synced at the same time, and that data is being pushed up to the cloud and pushed down to the devices, to the channel that they're subscribed to. We also have REST APIs for the Sync Gateway. So it allows you to do easy administration. You can connect to the REST APIs as an admin and perform several operations, management operations. And then seamless scale-out. Obviously, one Sync Gateway might not be sufficient, depending on the kind of application you're building. You might want to add more. And you can seamlessly add Sync Gateways to your cloud. The benefit, and Chris keeps talking about this, is 10x reduction in development time. As a mobile developer, I don't want to spend time figuring out the network. Am I connected? Am I not? Am I do I need to have filtered replication, or do I need to do something else? And it gives you this ability to really, really easily write these sync functions, sync APIs, and sync as needed. It could be a filtered push. It could be a filtered pull down to your device or up to the cloud. So how does sync actually work? Collaborative using channels, right? So as I mentioned earlier, each document belongs to a channel. You can specify a group of channels that it belongs to. For example, If Chris and I are sharing some data, I might have my own personal channel with my information, and we might have a shared channel where we have combined mutual information that we're updating at the same time. And then for each device, each user, you can control which channels they have access to. So maybe if I don't want to give Chris access to my personal channel, I say, no way, unselect that. But we have the shared channel that still works. And this way, you can create multiple channels. So it's not just one or two. You can create 100 channels, depending on the kind of application that you're building. Another key power of the sync gateway and the device is replicate only a subset of documents. Because the device is obviously, they're going to get really big to be able to do local computationally heavy tasks. But in terms of storage, you probably have local attached or SANs at the back in your cloud. You may not have as much space on your device, and you only want to replicate a part of your data. It gives you the capability to filter down specific data as needed as well. And this is using the user-defined filter functions. And most importantly, we've added authentication, which is obviously extremely important, particularly in when you're talking over the WAN. This is something that's different from the way our clients on the server side talk to the server. On the server side, the clients are actually in the same data center, probably, right, talking back to the servers. But here, the devices are just talking over whatever network they have. Right now, you might be connected to the guest Wi-Fi. You might be on LTE, 3G, and it doesn't matter. And you need to authenticate. And so we've added Facebook, as well as Mozilla Persona support for authentication. And I think Chris will use Facebook today. So let's take a look at what that looks like visually. So if you have a piece of data, the two different colors represent the channels, if you will, the channels that the data belongs to. And as the data is being generated, you might want it to flow in different ways. I want only the purple data to go out to the 5th iPhone there, and the yellow piece of data to go only to the first one. And so that's actually how it works. That's how channels work, where you can route data based on the channels, based on the clients, and who has access to those channels. So it's a very powerful concept. We'll actually demo how it's done. So how do you get started? 0 to sync in 5 minutes. Let's actually talk a little bit about that. Chris?
All right, thanks, Dipti. It sure feels good to see all this stuff come to fruition. So, I want to thank Jens and Tron and Marty and Jessica and Wayne and the whole, everyone at Couchbase who's had a hand in making this happen, because it's been, a number of years since we began the research that's culminating in the release today. So I'm going to try to go a little bit in depth on the technology just for a few minutes, and then we'll talk in this afternoon's session where you'll really get a chance to get hands-on with the code and ask us the hard questions. And like, for instance, I won't be able to talk about the conflict detection and management right now, but we'll talk about that this afternoon. So yeah, in the next few minutes, I want to show you one application that's a little bit, not quite as exciting as the checkers that we saw earlier, but a little bit more everyday, and was really designed to show off the individual features of Couchbase Lite. So what I'll do is walk through a couple slides with screenshots of the app, and then we'll switch over to a demo and see it in action, and then drop back in and look at a little bit more code. So hopefully that's that'll give you a sense of what you'd be dealing with as a developer. So there's a lot of features, and I can't cover them all in just a few minutes. So I'll focus on 2 features on the device and one feature of the cloud. So we'll look at how CRUD operations are done over a RESTful style interface that is designed to work not only with native Cocoa and Objective-C or Java Android code, but also works seamlessly with Ajax and the web environment on the mobile device. So the application I'll show, as Dipti mentioned, is written using the PhoneGap framework, but the same rules would apply to Sentia or a number of other similar frameworks. So I'll show a little bit of code for doing these document CRUD operations, and then I'll also show what, as a developer, is I think should be a built-in feature of every database, And that's an API to give you live query updates so that when the underlying data changes, the UI changes. If you are, if you're familiar with writing any kind of UI code, data binding is always a big part of that. But what changes when you're in a synchronization environment is that the events that are causing your data model to update are not necessarily being generated by the user who's right there. So if you wire your application correctly, it sort of doesn't matter to your code whether it's the user who's poking on that screen right there that made the change, or if it's a user halfway across the world who's changed that same data item and it's come in via the network. So I'll show this live query capability, and then I'll also show the backend cloud. And as Dipti said, 10x developer productivity improvement. I think that's actually a little bit conservative, because if you go find the stories of people who've tried to build their own synchronization, they spent years on it. I mean, we spent years making Couchbase Lite, but that's so you can use it in 5 minutes. So if you can enable sync in your application in an afternoon of coding, that's a lot faster than it would have been to build your own conflict-aware, real-time network abstraction layer with an embedded database. Obviously, that's the benefit of using an open source embedded database on the device. So I'll show, we really spent a long time talking to users who were dealing with kind of like early generations of the technology and prototypes that we've had over the years, and what were the sticking points. And the big problem they were running into is, how do we do multi-tenancy? How do we do access control and routing data to channels, like Dipti was talking about? And people were building sort of their own ad hoc solutions on the back end, essentially out of duct tape. And we wanted to build something that was more seamless. So after months of banging our head against the wall, we came up with kind of the eureka moment and figured out it's essentially you write one JavaScript function, and I'll show that in more detail in a little bit. And inside that JavaScript function, you can declare who gets to see a particular data item, or whether or not a particular data item was modified correctly or incorrectly, as well as routing the data to the devices that are interested in it. So I'll show that toward the end. So here is the JSON documents that underlie the application that I'll demo. There's a third type to track the user profiles, but these are the main two items. It's really just a to-do list tracker, right? Nothing could be simpler than that. So there are lists, and then there are tasks. And a list has an owner and some members. And so, for instance, I own this grocery list, and I've shared it with my family. And the tasks then just belong to a particular list. And it's as simple as that. That's what we're storing in the embedded NoSQL database, and that's what flows via sync gateway and between devices. So I'll take these couple of screenshots first before I switch over to the demo, just so we're not flipping back and forth a lot. When you first open the app, you're presented with a screen with all your to-do lists on it. So here I've got a grocery list and a couple of demo lists. And this is, again, it's all rendered with HTML and JavaScript and PhoneGap. We also have a native Objective-C version of this same application, so you can kind of put the code up side by side and get a sense of what the differences would be there. And then it's using a view query from the embedded database right there on the device to populate this list and put the most recently created to-do list at the top. And when you type something in here and hit go, you have a new list. And so let's drill into one of these lists. Now that we're in a list, inside the grocery list, we can see that I already got coconut water, and I took a picture of the lettuce because I was really particular about which kind of lettuce to buy. So that's kind of the set of functionality that we'll be dealing with. So let me see if how the demo gods are feeling today. So I've got the application running on my phone, and I've got this. We'll try to do the sharing thing here. So, all right. Good. So I'll launch the application, and these are all the lists that I've sort of built over the weeks as I've been demoing this and trying it out. I can go into my Whole Foods list, and I can say, oh, I already got cheese, and it doesn't make sense to have an iPad on this list. Kind of clean it up a little bit, and maybe I'll add broccoli. So I've created an item. It's all just an embedded database on my local machine. But if I now go on my other iPad here that's running the same copy of the application and get into that same list, I can also say that I want to pick up some cider. I'm a big fan of hard cider, so I'll add that over here, and in a few seconds it will propagate back to this device. It's as simple as that. So let's go back over to the slides for a second and look at the code that was involved in getting us there. So when I check off an item on a task list, this is all the JavaScript code that runs. JavaScript is, and that's one reason people like it is that it's so concise. But all we're doing is calling this. I click the checkbox, and each list item in that list has an ID. So I call this function with the ID. We'll go and use this RESTful interface. This boils down to, in the web runtime, an XHR request. So we're running a GET against this URL that's based on the database and the document ID. Here's the document. We're just going to toggle whether or not it's checked and update its timestamp and put it back where we got it. And that's it. And you'll notice, because we're using this live query facility, the success callback, this is the function that gets called when I have actually gotten the response back from the database. When that REST response comes back and says, success, you've saved it. And without live query, the next thing you would do is have some code here that runs and refreshes the UI. There's just no point in having that code because it could be somebody halfway across the world on another phone toggle the checkbox. And so we can't rely on this code path updating the UI. So that's why I have an empty function here. So let's take a look now at how we update the UI with this kind of live query capability. There's a little more to the code than this, and we can, I'll show you it in the flesh in this afternoon session in the second cluster room after lunch. But the gist of it is, earlier, when the application bootstraps and first starts running, I've created a connection to the underlying data store that's kind of like a Comet or a WebSocket. Essentially, I just have a continuous event stream coming from the database. And every time something happens, I just call whatever function happens to be living on window.db changed. So I used a global variable. I hope that's OK with you guys. And every time the database changes, it calls whatever function happens to be living here. So when we're in a task view, we stick this function here. If we're in a different view, we would put the list of lists function here, or a function to draw the list of people that you can share a list with so that the UI is always up to date with the underlying data. And then when the event happens, we just make a local query using the view engine, which is the same MapReduce technique that's used with Couchbase Server in the cloud. But all this is happening on the device. And we're able to update this template. And I'm not going to drill into how I update the actual HTML. You can do it however you wanted. But in this case, I'm just replacing everything in the scrollable portion of the screen with the new data and applying a couple of event handlers that make it so that I can actually delete items. So it's as simple as that. One of the screens that you didn't get to see because I'm already logged in on my phone is, in this case, in this application, you log in with your Facebook account. So I'll switch back over to the demo app here. So we're still connected to my phone. And you can see, because I'm such a great UI artist, I used a happy face for the group of people who I'm sharing this list with. So I'm sharing it with a few people in this room, and I think, just for good measure, I'll add Tron to it. But I think Jessica might take a picture, and we'll see a picture from the audience perspective come up in one of these to-do items, or maybe in a new one. And so there's, that's the social features. So pictures take a little bit more time to round trip through the cloud and back, but there we go. And if I click that, I can see here we are. Someone said English breakfast tea, and I enjoy a good English breakfast tea. So it's an embedded database. I like to think of this JSON anywhere as, it's the data itself that is connected. And it starts to feel like that when you're developing. It's like this data is going to notify me when something matters. So that's kind of the. I think that's everything I want to show in the demo. But I do have a little bit more code to go with it. So when we created that photo attachment, this is just another example of the CRUD, and to give you a sense of the simplicity of working with the embedded database. It's all this code to take a photo, but there's only 2 lines in here that really have anything to do with the database. I'm going to load the document that I want to put the photo on. I'll modify that document to include the image data, and then I'll put it back. So again, I'm using that RESTful metaphor here. And it's, the database is such a small percentage of the code. Really, you're spending your time thinking about where you're adding value for your users, taking pictures, and how big do you want the picture to be, and all that sort of thing. So let's switch gears and talk about the invisible part, right? You're used to the part in your hand, but the part on the back end in the cloud can be, in a traditional 3-tier web services architecture, the headache, the part you spend most of your time and maybe have a big team dealing with. So we're able to replace. In the blog post I posted this morning, I did a ballparking of what an equivalent Ruby on Rails app would be to this functionality, and it's about 200 lines of Ruby on Rails, or probably more than that if you were doing a Java app. But we're replacing it with 20 to 30 lines of sync function code that runs as part of the configuration of the sync gateway. It's how you adapt to the sync gateway to your application, and this is essentially your entire cloud in this one page of code. So I don't want to dwell too much on exactly what's going on in this code, but I'm happy. I mean, it's basically hard to stop me from talking about it, so come grab me afterward, and we'll, I'll tell you what every line of code does. But essentially, there's 3 main, responsibilities. There's access control. There is provisioning channels and routing data to channels, and then there's update validation. So, in this case, we're requiring that items belong to a list. If you have an orphaned item, we won't let you sell it, or we won't let you save it. So that kind of stuff, that kind of application logic is, I think, probably 80% of what's going to go on in a traditional web services architecture anyway. And since we're doing away with having to translate between JSON and another format, it drastically simplifies what's happening on the back end. So if you want to get started and play around with this demo, you can go to this URL here, or just Google for To-Do Light PhoneGap, and it'll come right up. And it gives you the 5 minutes to awesome, where you should be able to go from, hopefully having done a little bit of mobile application development before, so you've got the toolchain installed, and just use that toolchain to get an application up and running in your local simulator or on your device. I didn't show it on stage, but if Tron was, modifying any data in that demo, he was doing it on Android. So this same app runs just fine, iOS or Android, no problem. There's another URL that I meant to put on here, but it's mobile.couchbase.com, and that will give you all the developer resources for getting started and joining the community. So with that, I want to thank you for joining us and encourage you to come to this afternoon's session. And if anyone has any questions for Dipti or myself, go ahead and ask them.
Right. Thanks, everyone.
Sure, yeah, let me talk a little about Couchbase Cloud. So the demo was using Couchbase Cloud. I neglected to mention that, but I used Couchbase Cloud because I'm a lazy developer, and it was built for lazy developers. We knew that we needed something to do that 5 minutes to awesome experience that didn't involve configuring and provisioning a whole set of servers. So Couchbase Cloud is currently an experimental sandbox. It's not meant for production, but it is meant to give you the developer experience. So you can develop your app, share it with your internal team. As soon as it's time to go to production, you'll probably want to then go through the steps of provisioning your own servers. But Couchbase Cloud, the developer workflow for installing an app in there is basically you tell us what URL you want your sync endpoint to be, and you tell us what you want your sync function to be. So you just drop your 20 lines of JavaScript in there, and that's it. Any other questions?
Just in a few words, how the blocks of application, the architecture, essentially.
Yeah, so
This code say that where does the UI sync?
sure. So Jens will be doing a whole presentation this afternoon in the cluster with the architecture. But essentially, you've got code in two places, right? You've got some code in the sync gateway. That's that sync function, the 20 lines of JavaScript. And then you've got whatever it is on the mobile device that is powering your UI. So whether that's Xamarin or Titanium or PhoneGap or native code, Android or iOS. And that's just going to be interacting with the database via embedded NoSQL database APIs. As far as the code that triggers and manages the synchronization, to a developer, that's essentially configuration. You tell your on-device code the URL in the cloud that it should sync with, and once you get logged in and authenticated either via Facebook or Mozilla Persona or custom authentication, then the data starts to flow. All right, thanks.
All right, thanks, everyone.